Humans understand the world through sights, sounds, and context without even trying. But computers? They only see ones and zeros. Every day, we generate a massive tornado of emails, photos, tweets, and audio clips. Teaching a machine to understand this mess seems almost impossible. This diagram shows how we solve that problem. To make sense of the chaos, all those photos and documents pass through a funnel that strips away the messiness, translating them into perfectly structured arrays of numbers. The result of that translation is called an embedding. It is simply a long list of numbers that captures the true meaning and context of whatever data went in. Think of embeddings as numeric fingerprints. They translate abstract, complicated human ideas into the only language machines can actually read. In data science, you will hear these lists of numbers called n-dimensional vectors. That sounds intimidating, but do not worry, it has absolutely nothing to do with 3D physical space. A dimension is just an independent numeric slot. It is a specific attribute of an object that we can measure and assign a value to. Picture a digital sound mixer board. When an AI model analyzes the word puppy, it adjusts thousands of sliders simultaneously. One measures formality, another measures size. It automatically locks all these invisible sliders into place to capture every trait. When those thousands of sliders lock into their final positions, that specific combination of numbers forms an exact, unique coordinate. So once the computer has these thousands of locked-in coordinates, what does it actually do with them? A vector database uses these numbers to plot a concept's location on a digital map. Similar words like dog and puppy land right next to each other. Unrelated words like toaster drop far away. AI measures this physical distance to determine relationships. Computers no longer need to read letters or memorize dictionary definitions. They bypass language entirely, using geometric distance to determine what things mean. This map works beautifully for words, but comparing completely different mediums, like trying to measure the similarity between a written poem and a painted picture, is much harder. Embeddings solve this by acting as universal adapters. They force all our messy, unorganized information into the exact same standardized shape. An icon of a dog, the word dog, and a barking waveform pass through the model, translating into identical arrays of numbers. Sharing this numeric format, they are plotted on our GPS map, clustering perfectly together based on meaning. Embeddings erase the boundaries between text, images, and sound. You are already using this technology every day without realizing it. Old search engines used to break when you misspelled a word or used a synonym because they only looked for exact text matches. Now, because engines measure distance instead of spelling, they find what you mean, even if you type the wrong letters. This exact same vector math drives recommendation algorithms, as shown in this interface visualization. The system compares the numerical coordinates of a new song or movie directly to your personal taste profile, matching you with fresh content instantly. By organizing the messiness of human expression into a numeric landscape, embeddings give machines a reliable way to navigate and find meaning in our world.